Hello everyone, myself Sandesh Godavi, studying in Sri Venkateswara College of Engineering, Department of Information Science and Engineering. Uh, Today's topic Intelligent Storage System. Subject is Storage Area Network, that is SAN 18CS822, the subject code. Introduction. Intelligent Storage System are feature-rich RAID array that provides high optimized I/O processing capabilities. These storage systems are configured with a large amount of memory called cache and multiple I/O paths and used sophisticated algorithms to meet the requirements of performance sensitivity applications. An intelligent storage system consists of four components. That is, this is the intelligent storage system. That is host, front-end, cache, backend, and physical disk. And we have front-end. Front-end provides the interface between the storage system and the host. It consists of two components, that is front-end ports and front-end controllers. A front-end has redundant controllers for high availability, and each controller consists multiple front-end ports that enable large number of hosts to connect to the intelligent storage system. Each front-end controller has processing logic that executes the appropriate transport protocols such as fiber channel, ISCSI, FinCon, and FCOE for storage connections. Front-end controllers rotate data uh, data to the data to and from the cache via internal data bus. When the cache receives the return data, the controller sends an acknowledgement message back to the host. Next, cache. Cache is a semiconductor memory where data is placed temporarily to reduce the time period to service I/O request from the host. Cache improves the storage system performance by isolating host from the mechanical delays associated with the rotating disk and hard disk drives, that is HDD. Rotating disk are the slowest components of an intelligent storage system. Data access on rotating disk usually takes several milliseconds because of the seek time and rotational latency. Accessing data from cache is faster and typically takes less time, in a millisecond. One intelligence array write data in first placed in cache and then write to the disk. This is the structure of cache. This is the disk and this is the cache. This is the page, data stored, and RAM connected to the disk. Structure of the cache. Cache is organized into pages, which is smallest unit of the cache allocation. The size of the cache page is configured according to the application's I/O size. Cache consists of the data store and the tagram. The data store holds the data where the tagram tracks the locations of the data in the data store and in the disk. Entries in the tagram includes where data is found in cache and where the data belongs on the disk. The tagram includes a direct bit flag, which indicates whether the data in cache has been um, committed to the disk. It also contains time-based information such as time of last access, which is used to identify cache information that has not been accessed for a long period and may be freed up. Next, backend. The backend provides an interface between the cache and the physical disk. It consists of two components, the backend ports and the backend controllers. The backend controllers data transfer between cache and the physical disk. From cache, data is sent to the backend and rotated to the destination disk. Physical disks are connected to the ports and on the backend. The backend controller communicates with the disk when performing read and write and also provides additional but limited temporary data storage. Algorithm implemented on backend controllers provides error detection and correction and also write functionality. For high data protection and high availability, storage systems are configured with dual controllers with multiple ports. And next, physical disk. A physical disk stores data persistently. Physical disks are connected to the backend storage controller and provide persistent data storage. Modern intelligent system storage provides support to a variety of disk drives with different speed and types such as FCs, SATA, and SAS and flash drives. They also support the use of mix of flash, FC, and SATA within the same. Next, types of intelligent storage system. It is active configuration and active passive configuration. An intelligent storage system is divided into following two categories: high-end storage system and mid-range storage system. High-end storage systems have been implemented with active configurations, whereas mid-range storage systems have been implemented with active passive configuration. The destination between these two implementations are becoming increasingly insignificant. High-end storage systems refer to active arrays and generally aimed at larger enterprises for centralizing corporate data. These arrays are designed with a large number of controllers and cache memory. Mid-range storage systems are also referred to as active-passive array, and they are best suited for small and medium-sized enterprises. The path to be control controller B remains passive on I/O activity is performed through this path. Mid-range storage systems are typically designed with two controllers and each of which contains host interface, cache write controller, and disk drive interface. Mid-range array is designed to meet the requirements of small and medium enterprises applications. Therefore, the host less storage capacity and cache than high-end storage arrays. These are also fewer front-end and ports for connections to host, but they ensure high redundancy and high performance for application with predictable workload. They are also supported array-based logical and remote replications. Thank you. If you like my video, please do like it.